Hey everybody, Mr. Miller here, bringing you another instructional video, and as always, I hope you're having an absolutely fantastic day today. It is Wednesday, April 18th, and it is a little bit after 3 o'clock, and what I thought I would do in this video is work out one of the homework problems for you as an additional example. Now, before I do that, a couple of things that I want to stress. I've already banged this drum several times in class. It is absolutely important that you can factor stuff. If factoring is still giving you trouble, will you please come and see me after school sometime soon? It needs to be like tomorrow. Because we're going to be using this factoring business for the next couple of weeks. It is not fun to be sitting in a class where you feel like you don't know what's going on. Right? It can be a very helpless feeling. But what you need to understand is you have the control to do something about it. You can come after school and spend some time with me and get some extra help. You can ask me questions in class like a lot of you do, which is great. But it is essential that you can factor and factor somewhat on the quick side. Now, if you stay after school, it doesn't have to be like an hour session. I'm not saying you need to commit yourself that long. Come spend 10, 15 minutes and do a couple of problems with me. We'll go over them. Long story short, the ball is in your court. You need to be able to factor. All right? With that said, here's what I recommend we do. The problem that I was going to work out is number 9, and if you've already worked out number 9 in the homework, great. In a little bit, I'm going to work it out. You can check your work and see if your work matches mine, see if your answer matches mine. If you haven't worked out number 9 yet, I really don't recommend that you just watch the video. What I recommend you do is pause it when I say pause the video, work it out on your own, and then hit play and see if your work and answer jives with mine. With that said, we're going to go ahead and get rolling here. If you haven't done number 9, pause that video, try number 9 on your own. If you choose not to pause the video, you know, if you just want to watch it, like you want to be on cruise control and just kind of watch the video, watch me work it out, work my magic, you'll still get something out of the video. You will benefit from it, but you're not going to maximize your benefit by just watching me do it. So please hit that pause button right now, sonny boy. Pause it, work out number 9, and then hit play. Check your work and answer against mine. All right, so let's work out number 9. Oh, need a pen. And what number 9 says on A6 is this. It says 10n cubed minus 20n squared plus 10n over 4n cubed minus 6n squared plus 2n. And what our task is to factor, cancel, cancel, cancel. We want to be able to factor stuff and then see if anything will cancel, and if stuff does cancel, we need to cancel it and then rewrite our leftovers. To begin, we need to first look at what's the GCF of the upstairs. What's the biggest number that divides into 10, 20, and 10? If you're thinking 10, good job. It is 10. Now, how many n's can we take out? We make that decision off of our exponents. So there's no magic or mystery to it, really. It's not elusive. It's clear. You determine the number of n's to take out by your exponents, and specifically we go by the smallest one. Don't know who that is, anyway. All right, so when we take 10n out, what's going to be left? Take out 10n. All right. What do I multiply this 10 by to take me back to the 10 I started with? Well, that would be a 1. Keep that in the back of your mind. I have 3 n's to start. I'm taking out 1. How many is that going to leave? That's going to leave 2, right? So I have 1n squared. 1n squared. But the 1 in front isn't really necessary. I don't need to keep it. If you keep it, it's not wrong. All right, it's fine if you keep it, but me personally, for when I'm doing work, I like to leave it off. What do I multiply 10 by to take me back to this minus 20? Okay, that would be negative 2. All right. I had 2 n's. I'm taking a single n out. That's going to leave a single n left. Now, what do I multiply 10 by to take me back to this 10? That would be 1. I had it in n. I'm taking an n out. How many n's are left? None. So the back end is going to be plus 1. I'm sorry for coughing into the microphone. I'm still not 100% right now. Okay, what's the GCF of the downstairs? Give it some thought. What do you think the GCF is? If you haven't worked the problem out, trying to ask you some questions to engage you. 2 what? How many n's can we take out? A single n, so 2n. That's what we can factor out. All right, so 2n, and now let's see what our leftovers are going to be. What do I multiply 2 by to take me to 4? That would be 2. Another way to do it is think of it like this. You ready? Watch this. Take the part in the original problem and divide it by the GCF. What is 4 divided by 2? That's 2. All right. I have 3 n's. I'm taking 1 out. That's going to leave 2. All right. Minus, what do I multiply 2 by to take me to 6? That would be 3. Another way to do it is you can just divide. 6 divided by 2 gives me 3. All right, how many n's do we have left? Uno, right? A single n. We started with 2. We're taking 1 out. That's going to leave 1. Finally, what do I multiply 2 by to take me to 2? The answer is 1. I had an n. I'm taking an n out, so there's no n's left. That means this entire back piece is going to become 1. I really am sorry for coughing in the video, but I just need you to deal with that. I can't help it. All right, now then, what we're going to do next is we're going to start factoring the stuff inside the parentheses, and let's do the harder factoring first. The top quadratic is what I call naked because there's a 1 in front of the n squared. The bottom quadratic is dressed or clothed, as some of you like to say, and I like that because there's a 2 in front. So let's do the harder one first. The one that's dressed is going to require more work because we're going to have to do that stinking table. N plus 1. So we go front end times back end. Bada bing, bada boom. 2 times 1, that's 2. So I need 2 numbers that multiply to 2. But those same 2 numbers have to add to negative 3. What's going on here? To 1. Oh, no, to 2. To 2. All right, and then those same 2 numbers have to add, which is negative 3. All right, what 2 numbers make that magic come together? Negative 2, negative 1. Okay, fabulous. Not my singing, just the fact that I got the numbers right. All right, let's do it. Table time. Table time's always a great time. First piece, first box, 2n squared. Last piece, last box, a 1. Along this diagonal, we're going to drop in these 2 numbers. Their placement doesn't matter. Just pick a spot and leave them be. All right, now we start taking out. Here we go with GCFs again. So it's not really anything new that you're doing because we had to do GCFs up here. We're doing the same thing down here. So the GCF of 2 and 2 is 2. We go by the smaller exponent. We can take out a single n. GCF of 1 and 1 is 1. How we determine the sign is we look at our neighbor right next door. It's negative, which means our GCF is going to be negative. First column, GCF of 2 and 1 is 1. How many n's can we take out? A single n. Last column, GCF of 2 and 1 is still 1, but our lower neighbor now is negative, which means the GCF will be negative. Now, what we've just found, where am I at? What I've just found is how in this set of parentheses factors, please don't forget your child in the mall. The 2n is still part of the answer. Don't leave your child at the mall. That's terrible parenting. All right. Inside our parentheses now, we're going to have 2n minus 1 in one set. And we're going to have n minus 1 in the other set of parentheses. Right? We're almost there, guys. We're almost there. How are we doing on time with this video? Oh my God, it's already over 10 minutes. I'm sorry about that. But suck it up and deal with it, please. I'm trying to help you. Is that mean? Am I being mean? I'm sorry if that's mean. But you know what? Too bad. Deal with it. Okay, I'm kidding. All right. I gotta stop. I gotta stop. All right. This is a naked quadratic. What two numbers multiply to positive 1, but those same two numbers add to negative 2? Negative 1, negative 1. Right? Now, naked is good because naked means you're not obligated to do the table. Now, some people like to do the table even if the quadratic is naked, and hey, that's cool. There's nothing wrong with that. More power to you. You got to use what works for you. But, I'm sorry again for coughing into the mic. For those of you don't like the table, the naked quadratics are pretty nice then because you don't have to use it. N squared is going to break up as n and n. And then we're going to drop in these two numbers in the remaining spaces, minus 1, minus 1. All right, now let's see. This is where the fun part comes in. This is where you get to come in like Han Solo with a lightsaber, and you're just going to start slashing common factors. So what things could we get rid of? Well, let's see what matches up. We have an n minus 1 in the top, and we have an n minus 1 in the bottom. We can cancel out an n minus 1 in the top with an n minus 1 in the bottom. When those two n minus 1s cancel out, in effect, they're gone. They've turned into 1. Which means, if you're thinking, hey, I got another n minus 1 here, I'll also cancel that one out. Oh my God, don't you dare do that. You can't do that. You only have one factor of n minus 1 in the downstairs. So once you get rid of that factor, you cannot somehow get rid of this n minus 1. This n minus 1 is a keeper. You're stuck with it. I'm sorry. Now, what else could we cancel? Well, we can cancel the 10 and the 2, but how? Well, what number goes into 2 and 10? 2, right? 10 divided by 2 is 5. 2 divided by 2 is 1. Beautiful. The last thing that we can do is cancel out these factors of n. Okay? The reason why we can cancel those out is because of what I just said. They're factors. Okay? They're factors. They're not separated by a plus or a minus, so it's perfectly okay to cancel these n's out that are on the outside. Now, here's what would be wrong. It would be wrong to say something crazy like, oh, look at, I've got an n here. I've got an n there. I'll cancel those out, right? Wrong. You can't do that. This n is separated by a minus, and that n is separated by a minus. You can't do that. You can only cancel out factors, and I went over that in the introductory PowerPoint on simplifying rational expressions. Okay, guys, we're almost done. We're going to now bring this home and write the final answer out. What is left over is our final answer. So let's take a look at the top. We've got 5 and then n minus 1. And I think that's it. Do you agree? All right, very good. How about the downstairs? 2n minus 1 is the only thing that's left. Okay, you could say, yeah, but you got a 1 there, but what's 1 times 2n minus 1? 2n minus 1, right? So you don't have to write 1 parentheses 2n minus 1, right? So there you have it. This is our final answer. And hey, it only took what? How many minutes to get there? 15 minutes to get there. But you know what? It was worth the ride. And I hope you found this video useful. Feel free to hit me up with questions through email. And guys, I really appreciate you taking the time to watch this video, and I really enjoy working with you. I will see you when I see you. Take care. Bye.